So you guys have heard the words Dart Dev Compiler, or DDC. What is it? We talked about it a little bit last year at last year's summit. It is a new Dart to JavaScript compiler. It is not intended to replace Dart to JS, but to be a complement to it. DDC is very much focused on development on browsers. And in fact, one of the first questions we asked when we started DDC is, what would it take to provide a Dartium-like experience in regular Chrome? What would it take to let developers have that same sort of fast iteration experience on regular Chrome? And how can they take advantage, for example, of the browser developer tools, the way we've added hooks into Dartium? We're also very much interested in providing a very strong error checking experience as part of DDC. Leaf talked about this quite a bit in the last talk. Strong Mode and DDC are very integrated to provide a nice static plus runtime error checking experience. It's very important when you're developing code. We also want to support other browsers. This is what we can do by compiling to JavaScript quickly. And we have support for things like source maps, but we also want to make it possible to drop into JavaScript and see readable, debuggable JavaScript for people who need to go down to that level. And then finally, a theme I'll hit on a little bit later is we also want to make it very easy to integrate into any kind of standard build tool, whether it be our own internal tools at Google or any other tools. And I'll have a demo that talks a little bit about that. Development's been our main theme, but kind of a secondary theme that will come through is that DDC is a platform for JavaScript interoperability. This dovetails actually quite a bit with our goals for development. We want to be able to generate readable JavaScript code, and what we really try to do as much as possible, just target idiomatic ECMAScript 6 code. So Dart classes map to JavaScript classes, Dart methods map to JavaScript methods, properties to properties, getters and setters to getters and setters, with minimal name mangling. And another part of this is also to actually take advantage of JavaScript module frameworks. So to map Dart modules into standard JavaScript modules such as Node or AMD or the forthcoming ES6 module system, and play well with those. Leaf talked a little bit about soundness, and soundness ties in a lot to DDC, and I want to talk a little bit about that before I go on. Standard Dart is intentionally unsound by design. And this is a bit of a pop quiz to see if you were paying attention to Leaf's talk. If I have a list of numbers and I add the first two elements together, what can happen? Anybody, it's pop quiz. A lot of things. No. Absolutely anything is probably right. A developer would reasonably think, okay, well, it could throw a null pointer exception. List could be null, that's true. It could throw an array out of bounds exception. The list might not have two elements. You kind of think or hope that most of the time it would print a number, but it could be anything. This is legal Dart code. And interestingly, you won't get in standard Dart any static errors or runtime failures, even if you're running in check mode. You can pass in strings, you can even pass in cats, as you saw, or anything else. So that makes it challenging. There's an interesting implication to this for those of us who are actually developing tools or writing compilers, or even for developers who are trying to reason about the code. And that's that we can't really use those static type annotations, or we couldn't before. The static type of that expression, adding the two lists, is num, but the compiler can't assume that that's a numeric operation. We can't just generate standard JavaScript plus if we are generating code from that. It could be anything. Dart has operator overloading, so even though it's plus would work for string, it wouldn't work for a cat. I'm not sure exactly how you'd add two cats, but those things can happen, I suppose. So what many people are a little bit surprised about is that Dart to JS doesn't really use static types to generate code, right? It actually drops the type information and recovers it all in a more sound way, but it's not using the static types that you as a programmer write. This isn't actually that unusual. In fact, pretty much every common JavaScript, typed JavaScript variant, and there's a bunch of them now, are also unsound. And so here's effectively the same example in TypeScript, no static errors or warnings, prints hello world. I have a list of numbers here at the top. I can just populate that with strings. I'm not going to get an error or warning in TypeScript. Of course, in TypeScript, code generation is just type erasure, right? So you have that number annotation there. All we have to do is get rid of it. That's fine. TypeScript types, by design, aren't intended for compilers to use. I don't think any tools actually try to use them to do optimization, for example. Dart is not JavaScript. That's a good thing. I think you guys wouldn't be here if it was. But we often get this question about compilation, right? So let's take this fragment of Dart code here. Why can't we just translate that to the same JavaScript? That fragment is conveniently legal JavaScript and Dart. Why is that different? Well, the semantics are different. And I hope you agree with me that this is a good thing. And just to go into detail a little bit here, if A doesn't happen to have a bar field here, in Dart, you're just going to get an error, right? In JavaScript, well, we'll just throw undefined and keep trucking along, and who knows what's going to happen, right? Same thing with methods. If we pass in too few or too many, in Dart, you get an error. In JavaScript, they just figure out some way to keep trucking along. So again, we think this is a really good thing about Dart. We certainly don't want to change that. Dart has fail-fast semantics. You don't want to just keep trucking. If you're writing serious applications, we believe undefined behavior is bad. And you want, as a developer, to know about these errors as soon as possible. And even if you ship the code out, you don't really want undefined behavior happening in your applications. This does come at a cost, though, right? So if you take that bit of JavaScript, or Dart, sorry, what Dart2JS does in the general case is to generate something that looks like this. And these interceptor objects are basically what's doing the dispatch in Dart2JS to make sure the right things happen. So if you looked at generated code, sometimes you might see these things. Now, Dart2JS is an aggressive whole program optimizing compiler. And a lot of times, it's able to get rid of a lot of this overhead, but you might not, what you should get at the end might be pretty efficient, but might not look a lot like what you started with, and it takes quite a bit of time to do that. So DDC is very much tied to strong mode to be able to generate reasonably nice code very quickly. And we take advantage of the fact that we can now trust with strong mode the type checks. So if this little snippet of code here now type checks in strong mode and A and B are statically typed, then we at compile time know that A.bar can't throw a no such method exception and B.foo can't either. And that means that we can actually generate more or less the same JavaScript code, right? So the JavaScript you get out looks a lot like the Dart that you get in. So safety is basically, you get a lot of the same safety properties, but most of them are actually enforced statically. As Leaf said, not all of them, but most of them are actually enforced statically, and DDC can generate code that takes advantage of that. Implication, of course, is that DDC requires strong mode, but that's what you're getting out of it, just to be clear. So type checking is sort of one aspect of modularity. We're kind of rethinking a lot of the build system here with DDC. We can modularly type check things. That means that we can do the type checking locally on a module without having the entire program. If the module type checks, we can do modular type-driven code generation. We don't need the whole program. We can use the types there to generate nice code. That lets us plug into modular build systems, whether you're old school and like to use makefiles, or you want to use something as advanced as Bazel, which is Google's build system, and there'll be a talk on that tomorrow, and I'll talk a little bit about that later. You can also generate modules, JavaScript modules, for example, and play nicely with deployment tools that are out there, like Webpack, right? We just generate modules, Webpack can consume them. So I'll actually have a demo, and this is going to be based on the Captain's Log app from yesterday's Code Lab using DDC. Who did that Code Lab, just to show of hands quickly? Yeah, several of you managed to do that. Great. Yesterday's Code Lab was showing DDC working with Bazel, which is our new build system, and you'll learn more about that tomorrow. And I'll talk a little bit about that later. But I have a different variant here that works with Node modules and Webpack just to show you the flexibility in the system, right? So what we're going to do with DDC is that we're going to take this app and we're going to compile it down to different modules, and we just basically do this at a package granularity in Dart. So you'll see essentially 5 different modules in the system. The SDK, package.js, which we're going to use to talk to a WYSIWYG editor called Quill.js. Those of you who actually ran the Code Lab have seen it. And Jacob will talk a little bit about that in about 20 minutes. Package func, which has some nice function utilities. The package that's part of the app itself, the Captain's Log. And then a main driver app to build it all together. There's kind of a make-based build. I should say, I found out I had to give a demo. Well, actually, I wanted to give a demo. Wanted to do something cool. Someone told me about Webpack. I'd never used Webpack before. And so this actually came together pretty quickly. I ran Webpack for the first time and then got something more or less running in about 5 or 6 hours. But it's glued together with Make to kind of drive the Dart building and Webpack to do the bundling and serving. And let's take a look. So first of all, this is a make file that basically shows you how you can invoke DDC. Unlike Dart2JS, it's not a whole program compiler. I don't know how many of you are familiar with make files, but they're very simple. Target on the left, sources on the right. If js.dart changes, we invoke DDC to produce js.js. Similarly with the func package, captain's log is a little bit more interesting. We take 2 Dart files, and we take summaries, and we invoke DDC. These summaries basically just mean that captain's log depends on these modules up there. The summary is just an API level summarization of those libraries. So if you're editing something up here and the APIs didn't change, the build short circuits. You don't have to build anything else. And then finally, the main.js at the bottom, which ties it all together and also takes in summaries. So again, if you're editing the captain's log, you don't affect the API. Main won't get built. So I'm lying a little bit. I actually ended up wrapping this up in a Dart watcher thing because I didn't want to type make. And you can see it's kind of running in the background, looking for things, and just running the minimal build step. In most of the cases, I'm going to be editing just this captain's log, and it will build the minimal thing. I have Webpack sitting on the side, listening to changes in the produced JavaScript, and serving it up. So let's actually see. So DDC and Webpack don't actually know anything about each other, but they talk the same module format. So it actually was surprisingly straightforward to glue these things together. This is the Webpack entry point. I just use node-style require statements to pull in the Dart SDK and the main app. The Dart SDK is just used to actually set some cool tools in the debugger in DevTools in Chrome, and I'll get back to that in a moment. But all this is really doing is firing off the main entry point in the application. Of course, there's this interesting bit of code in the middle here. Webpack has support for hot module reloading. DDC doesn't know anything about hot module reloading, but it doesn't actually need to, because again, we're just talking the same modules. So as soon as Webpack sends out a signal, I just have a listener here that listens for it, calls clear on my Dart application, does a require to load the new version, and just calls the entry point on that. So let's see this in action. This is the captain's log app. Firefox, Safari, Chrome, all running at the same time. Let's make some interesting changes here. So we've got these start dates at the bottom. This is the WYSIWYG editor called Quill, embedded. Jacob will talk a little bit about how that works. You enter stuff in here, it shows up in your log. We have star dates. These star dates look awfully lot like Earth dates, 2016. That looks a little suspicious. So let's just make a simple change. I've conveniently put this at the bottom. I'll save it. And we'll go back, and you can see Earth date shows up everywhere, more or less immediately. That might have been too quick. All right, notice how there's a toolbar up here. Turns out Quill has different themes. You can play around with that too. So let's go here and change from the snow theme to the bubble theme. And we now have the bubble theme here. What happened to my toolbar? Bubble uses tool tips. So I can check that, hey, this renders on all my browsers. And again, it's just reloading it on the fly. We didn't actually have to reset the state. You can see I'm in the middle of editing something. If I reload it, the this is Chrome part disappears. But it's all just happening live here. So that's cool. We get a lot of stuff for free just by designing our system modularly, right? I didn't really spend a whole lot of time trying to get Webpack working. It's just happened to work. So hopefully we'll get a lot of those features. Let me show a little bit about debugging. So Webpack does support source maps, and it can handle the source maps that DDC changes, but I have to run it in this debug mode. And that just makes things like a half second slower, so I found that kind of annoying. But let's start it up again. The apps are reloading here. You can see the text that I had written is all gone, but we're now live again. And let's zoom out here in Chrome and start looking at the dev tools here. So I have a breakpoint. Let's see if I've actually saved it. Yep. So I set a breakpoint here. And as you can see, we're in Dart source. This is captainslog.dart. I'm at the breakpoint in the Dart code itself, right? And so even though I'm in regular Chrome, I get a pretty nice to look at stack trace here. So save log here is the handler that gets registered on the button. And we stopped here in append to log, which is getting called from that. And what's kind of cool here is that we have hooks in the dev tools, which Dan talked about earlier. So when you actually, hover over log entries, you actually see the Dart type. It's a JS linked hash map, and you see the reified type information, right? So we're keeping all of that in there. We're using it and enforcing it, the safety of it. And the nice thing is when you are developing, when you're debugging, you see that type information. And you also see a nice Darty view of the hash map. You get the double keys and the values. And you can even drill down on that and expand and look at the div itself if you wanted, right? So you get a nice DevTools experience because we're saving all this information and displaying it to you in a nice way. One final thing I just want to show here is when we do the hot update, what actually is happening here. So let's go back and actually change that thing back to snow, which I like better anyway. And we'll see that it gets slightly slower, but it gets reloaded. And these two things come down the pipe. And it's just a message that's showing some information, and it's only sending the minimal thing down, right? It's not resending the Dart SDK or any other packages. It's just generating, I edited Captain's log, I'm getting Captain's log JS down the pipe. This gives us a good chance to take a look at JavaScript. So we can see that this code got generated with the snow theme, and that was effectively the update. So, it sent the whole package. I guess it could have done a smarter diff, but I don't really know a whole lot about how Webpack works. That's kind of the point of the demo, actually, right? So just to show like an example of what the code looks like, though, it's not perfectly idiomatic Dart code, but it's pretty readable. So for example, calculate start date is clearly a function with the name that matches the original Dart name. We're calling into the core library to create a date time, a couple date times with different arguments and different constructors, as you can see. We're calling the difference method. We're doing add. You can notice this is one case where we actually have to do some runtime checking in DDC. We don't know from the type system yet that we have a non-nullable number here, so we have to do a null check. Of course, if the type system told us these things, we'd get better code, so we're always asking for that kind of stuff. In this case, we happen to know that this is a private member to the package, so we know that that one's not null, so we don't have to check that. But in general, we love things in the type system. All right. So let's see, that's the demo. Again, this was something I quickly put together. All the code is up here in GitHub. All the code is there. I promise to actually put instructions in the next couple of days before the summit is done, if anyone's interested in actually reproducing this. So I mentioned I just spent like a day or so hacking up Webpack just to show that it would work. We've been very much focused in the past year internally with DDC. And there's a good reason for that, right? We wanted to, well, first of all, we have all these teams that pay us, are basically paying us. So we got to do that. But we also wanted to prove that anything that we do works at scale, right? We need to scale to many, many megabytes of code to run our internal applications, to provide a good developer experience for these applications. And we wanted to prove it there, right? At size of code, at a complex set of web of dependencies. And we felt that if we could prove it here, then we could take it to the small, like I did with Webpack, and get things to work pretty quickly and get our assumptions right. So part of the complexity here is just all of these dependencies, right? We have the Dart SDK. We have all kinds of packages in pub. We have Angular Dart, which you saw about today. We have all these cool Angular Dart components, which you saw earlier today. We had a lot of common internal infrastructure, some of it UI, some of it other stuff. We have components on our own application. You know, an application author will have their own components, and they'll have a main app, again, that weaves this all together. It's also not just Dart code. Farhat Matan talked about this a little bit today, but Angular templates, they have a generation process to turn those templates into Dart code. We have things like protocol buffers that we use for serialization, where you can change specifications and it generates Dart code. And all of these are part of our build framework, right? And the thing we've been focusing on is making this work in Bazel. And you'll hear more about that tomorrow, but Bazel gives you parallelism, it gives you caching. It's really a great tool to build large apps at scalability and speed. And I can't show the app itself, it's an internal app, but I'm just gonna walk you through the life of an edit. Let's suppose we're editing one of our components. Most of our app authors are not necessarily here, but they're often here. They're usually not all the way down here, right? And we wanna make the incremental build process work really well for them. So let's suppose we're editing one of our own table components inside of our app. It's an Angular component. So step one here is to actually generate from the templates, take Dart and HTML templates and produce Dart. And in this particular case, that took about 200 milliseconds. Now I have a Dart library. So step two in this build process, this is basically kicked off as soon as you do an edit, is to build the summary, right? And that takes about, in this case, a little bit less than 300 milliseconds. Step three is to actually build the JavaScript corresponding to this component, but we don't have to wait for the summary. As soon as we have the Dart library, we start kicking that off in parallel right there. The summary, like I mentioned, you saw this in the makefile, is used to inform downscale dependencies, right? So if we have downstream dependencies, so if we have something using table, we use the summary to type check it. And in this case, the edit happened to change the summary. So I have to build another component library that depends on that table. So for this change, I had some cascading dependencies. I build that summary. Again, you can show, this is basically a timeline here. So this is actually happening while I'm doing DDC on another thread. I can also start compiling that new component. That happens to be a fairly big one, so it took a little bit of time. And then finally, I had a main app that I needed to compile too. And the cool thing about this particular example is I have three different things compiling, but at some point in time, they're all happening in parallel. So I'm taking advantage of the parallelism on my workstation, and if I want to do this at scale, well, Google has nice infrastructure for parallel builds. And then finally, when all these things are done, I just bundle it up, and I'm done. And this whole thing took a little bit over a second. So that's the kind of experience that we can get when you do this at a much larger scale. Many changes are local. So if I was doing a local change that didn't cascade out of the table component, I'd basically be done at this point right here and able to bundle it. So in that kind of more common case, this would take more like half a second. So to summarize, what do you get from DDC? You get a fast modular rebuild. You get readable ES6 code. You get nice iterative development on multiple browsers. And we've done a lot of extra work in Chrome, DevTools support with Chrome. And Jacob promised if I left him extra time, he'll actually do a demo that will show even cooler things than I was able to get into. As Leaf talked about soundness and strong mode, DDC works very nicely with strong mode. It requires strong mode, but it exploits it quite nicely. The status, it's still kind of in a beta state, but it is actually being used by several teams internally for their day-to-day development. As I mentioned, our initial focus is Chrome, but we are now in the Dart SDK. We used to be in a different GitHub location. We've moved. You can find our code over here. As Kevin mentioned, or Bob, we are the Dart Dev C binary now in the SDK as of somewhat recently. And we still have the mailing list. You can chime in with questions and hopefully get some answers. But that's basically what we got. Thank you.